Have you ever wondered if Windows experiences from the cloud could be like local? If yes, then you're in the right session. I'm Sandeep, and I lead the Like Local team here at Microsoft, and I'm joined by my esteemed colleagues and a wonderful team who I'm blessed to work with, Rinku, Ang, and Jordan.
Hi, I'm Rinku. I'm a senior product manager in Sandeep's team. I'm responsible for transport and connectivity space.
Hi, I'm Ang on Sandeep's team, working on Like Local features. I'm a senior product manager, and my areas of responsibility include graphics performance and connection time.
Hey y'all, I'm Jordan Marchese, product manager on Sandeep's team as well. I own redirections, whether they're peripheral or device state.
At Microsoft, we strive to understand the unique needs of each of our users. In this particular case, the user is a game developer who has graphics-heavy workloads. The user has needs such as two 4K monitors running at 60 FPS, with the screens being very clear and smooth. The connections to be instant and reliable, and the peripherals like pen and any of the storage to be real-time and responsive. Now, of course, they also care about the applications that run on the cloud PC or their AVD VM. They would want them to be performant. So, for example, they're running Visual Studio where they're building 2D or 3D game development software or games. And of course, things like Blender where they have animations that they build and they want it to be smooth running at 60 FPS, as well as support for next-gen 3D graphics engines built right into the OS, in the instance of the cloud PC even. If it is a third-party software, the IT can easily add them. Now imagine when that happens, we need to go and strive to deliver something that's beyond just let it just work. We have to innovate, we have to invent to be able to deliver like local experiences. Moving on, let's take a look at what it really means to deliver like local experience and how we adapt to the user's environment. Let me start off by saying that there's a baseline that we have. And in this case, the baseline is the connection success has to be 99.9%. The reliability should be more than 8 hours. Now, what does 8 hours mean? We're talking about the mean time to failure, which is from when the user connects to the first unexpected disconnect should be no less than 8 hours. Ideally, we want that never to happen, and that's the 99.9% of the case. But then when it happens, it should be at least 8 hours of gap between the two. Then the other requirement we're looking at is the endpoint itself, where we're trying to get to a point where the endpoint requirements are minimized to what's necessary for what the user has next to them: keyboard, mouse, pen, camera, and such. Now let's look at some of the environment around this. There is graphics throughput that goes over the network, and the bandwidth plays a big role there. To be able to deliver two 4K monitors at 60 FPS, we would want to achieve that at 60 Mbps, no more than that. Similarly, end-to-end latency for all these devices. Let's say you have a pen, you're writing on it, you want to make sure that the tip of the pen and where the ink line is should be right next to each other, just like local. Now, to be able to achieve that, we have to do some inventions that we talked about. So what we're trying to see is if the user has 30 millisecond latency or less, we are able to support all peripherals just like local. Now, of course, this is the best case scenario, which is like local. And the reality of life is the network performance goes up and down. And we want to make sure that our software, our technology adapts to this and gracefully degrades to be able to deliver a performance and experience that is acceptable to the user. Now, this is why you see where we say the min required is half Mbps, which means if it goes below that, we will rather not give you a connection than give you suboptimal connection. Similarly, with latency, if it is more than 175 milliseconds, it is going to be bad. So at some point beyond 175, we should say, you know what, let's go fix your network or get to a place where the network is more reliable to be able to give you a near like local experience if you have the best, or a minimal acceptable experience. Now let's look at a couple of things here. Time to connect. I talked about speed to connect, instant connection, and all that. One of the things that we have heard from our users is, hey, on my local device, I get to my device, I put in my credential, and bam, it's available. But from a cloud, it is not that way. And that's the reality. And we have to, again, innovate or invent to be able to do stuff. So let's look at the connection time. Here, there's a small demo running there, and we have started the connection. It takes about 30 seconds. And what's coming up pretty soon is the ability to connect less than 10 seconds. On the right, you see the connection started and connected even before the left could finish its connection, even though I started much later. And I intentionally did that so that it was very visible. So again, making sure the connection success and the endpoint requirements stay the same, we are able to deliver a much faster connection to your cloud endpoints. Now, this is not where we're going to stop. We are going to continue improving almost like local. These were some of the demos to establish what we're doing, but let's look at a little bit of deeper analysis of exactly what's happening. So we as Microsoft have the luxury and the responsibility to be able to deliver this because of the relationships we have with our partners, as well as the technology that we own. In this case, we talk about silicon partners, NVIDIA, Intel, AMD, and all Qualcomm, all of them. We are working with them to deliver the best silicon for remoting experiences. Working with systems, everything that runs on top of that, all the matrix multiplications, all the other such complex things can happen at a silicon level so that we can deliver this experience. At Windows, Microsoft owns the OS. We are building a lot of technology and innovation into it to be able to deliver things. And then, of course, the Windows Cloud, which is who we are, the Windows Cloud team delivering Windows 365 and Azure Virtual Desktop technologies. A lot of innovations coming there. And of course, streaming, which is what you've been seeing, which is directly the team that you're talking to right now is responsible for. All right, now let's look at what we have delivered in each of these areas recently and what's coming up soon. In the streaming area, we delivered RDP ShortPath and support for TURN. Now, ShortPath, as the name suggests, is us trying to establish the shortest path between the client endpoint and your Windows in the cloud. This, physics comes into play, and the closest path generally gives you the best experience. And with TURN, we're trying to use relay servers and UDP as well. And by the way, both of them use UDP. And because of what UDP is, it allows us to deliver frames faster than TCP by itself. So therefore, a lot of reliability and MTTF increase comes in as a part of this. In Windows Cloud, we also have added a number of features that delivers rich experiences like local. For example, multimedia redirection, where we have support for up to 50 websites, where the video is streamed locally to the endpoint and then played there. Then we have support for real-time communications apps like Microsoft Teams, Zoom, Cisco WebEx, and so on. We have support for single sign-on with Microsoft Entra ID, and then support for popular endpoints like Windows, Web, macOS, iOS, Android, and a number of Linux endpoints as well. At the Windows level, we have made updates and some innovations in the areas of passwordless authentication, as well as faster sign-in. The faster sign-in is a lot to do with how we interact with the libraries that built right into Windows so that we are optimized the way we are able to pass on tokens and be able to do some of these authentication faster than we were able to do before. At the system level, we have brought support for hardware encode and decode of HEVC. And for graphics quality, we have support for both 444 with H.264 and 420 with HEVC. At the silicon level, like I mentioned before, we are working with GPU and CPU silicon providers to optimize the way their silicon is built. Now, let's look at what's in development and coming soon. We have RDP Multipath, where we try to establish connections over multiple paths at the same time, multiple UDP connections, multiple TCP connections between the same pair of endpoint and your Windows in the cloud. With this, we are able to deliver higher reliability and longer MTTF just because when one connection drops, we are able to fall back to another one. Rinku will be showing a demo of this later in this session. We're also working on fast connection, where it went from 30 seconds down to 10 seconds. We're trying to see if we can go faster than that. Later, we'll also show a demo of drive and folder enumeration performance, where we are able to go faster when you have thousands of files in a folder. We're able to enumerate that and be able to provide details much faster. Of course, we are improving the performance of peripherals so that when you have a device, let's say a scanner or a pen or camera, we are able to deliver performance just like local. Now, let's go ahead and look at a demo of RDP Multipath. Over to Rinku.
Let's dive into the demo of RDP Multipath, a feature designed to significantly reduce the recovery time in an event of a network disconnect. First and foremost, one of the most important aspects of RDP Multipath is that it requires no changes or network configurations to be done by the IT or by the end users. Everyone can benefit from enhanced connectivity without any additional efforts. RDP Multipath continuously monitor multiple network paths and intelligently switches between them real time. If one connection fails, it switches to the alternate path almost instantaneously, maintaining uninterrupted connectivity. One of the most impressive benefits of this feature is that it has improvement in mean time to failure, as Sandeep mentioned. Previously, the MTTF was around 2.5 to 3 hours. With RDP Multipath, it extends to about up to 8 hours. This improvement means that most users can now work throughout their entire day without experiencing any disconnects. Additionally, we have managed to lower the disconnect rate by 30%, which further improves user productivity and experience. To illustrate this point visually, we have an Azure Virtual Desktop setup with 2 network interface card, and in order to cause a network disruption, we are going to disconnect the active Ethernet port or the network interface card. So on the left side of the slide, you see what happens today when there's a network disconnect. A reconnect screen appears and that can last for up to 1 minute. On the right-hand side with RDP Multipath, when we disable the Ethernet point, there is no reconnect screen at all. It just continuously works. What it happens is that we switch to the alternate path behind the scenes, and it happens within milliseconds without the user even coming to know that a network disconnection or interruption had happened. This feature will apply for both AVD as well as Windows 365. So overall, this feature represents a significant win for all of our end users and customers by providing uninterrupted connectivity and enhancing overall productivity. We are making a major move by increasing the number of regions where our TURN relay is available. Currently, we are available in 14 regions, and we will expand to 43 regions globally soon. With more regions, we can serve users from more geographically diverse locations, which allows us to significantly reduce latency. In short, data has a short distance to travel, meaning faster connections and less lag for the users. More regional coverage also improves overall connection reliability. Users will experience fewer connection drops and more stable connection. Ultimately, there will be also much higher chances for user to get UDP. What this means is that the users who are sending voice, video, or any real-time data will enjoy smoother, more dependable performance even under varying or low network conditions. Additionally, we are moving to dedicated relays that has been specially tailored for AVD and Windows 365 traffic. First, because we have our own dedicated IP range and relay uniquely scoped for AVD and Windows 365 traffic, it isolates and optimizes the traffic flowing through these channels. Second, It also creates a scenario where customers can better control and navigate potential limitations imposed by their own network security setups. By leveraging this IP range, the customers have flexibility to bypass certain network restriction. This means that the quality and speed of Azure Virtual Desktop and Windows 365 traffic aren't hindered or filtered by generic security measures designed for broader or non-optimized data. To conclude, the global expansion from 14 to 43 regions will empower us to improve latency and more reliable connections, enhancing performance and user experience across the platform.
How awesome was that? When was the last time when you did not notice your disconnect? Now, over to a demo of HEVC. Over to Ang.
Thank you, Sandeep. So, in addition to our GPU-enabled AVD virtual machines, last year saw general availability for our GPU-enabled Windows 365 cloud PCs. This unlocked the capability for our customers to use the power of dedicated graphical processing units on their CPCs to execute graphical workloads, such as 3D design, animation, and game development. Along with unlocking those graphical workloads on the host machine, these GPU-enabled remote machines were also able to take advantage of hardware-accelerated graphics encoding using, at the time, the HEVC codec. This resulted in improved latency and responsiveness by using the dedicated host GPU to perform graphics encoding instead of a CPU-based software encoder. Last fall, we went into public preview with the next iteration of our hardware-accelerated graphics encoder using the more efficient HEVC or H.265 codec. Compared to AVC, HEVC allows for 25 to 50% better data compression. This unlocks higher fidelity graphics experiences such as 4K resolution at 60 frames per second in lower bandwidth scenarios for our GPU CPC and AVD GPU-enabled VMs. This next slide will show a short demo of a user connecting to a GPU-enabled cloud PC, executing a build of a 3D animation in 4K at 60 frames per second while experiencing the output of their workload in the same fidelity for which it was rendered. In the Windows app, the user connects to their GPU-enabled cloud PC where the 3D rendering app is already running from a previous session. The user confirms the 4K output resolution and updates the frame rate to 60 frames per second before beginning the render process. The user disconnects from the cloud PC and returns about 30 minutes later to find a completed render. The user is able to view the output on their 4K monitor and confirm 60 FPS using the connection information bar. HEVC graphics acceleration is currently in public preview, and you can learn more at the Enable GPU Acceleration for AVD article at learn.microsoft.com. Now, following my graphics demonstration, I'll pass it off to Ang to talk about connection time improvements. Thank you, Ang. All right, so another area of the cloud PC experience that we're laser focused on in our Like Local team is the time it takes for users to connect to their cloud PCs. Recent improvements we've made have focused on service level improvements, which accrue to faster connection times for our customers. 4 examples of such recent improvements include optimizations to the way auth tokens are created and acquired for client endpoint to cloud PC pairs. We've also introduced an enhanced authentication protocol, which improves the authentication time it takes during a connection establishment. We've also implemented RDP file caching to reduce the time it takes to retrieve RDP file for a reconnection. And finally, we've made changes in Windows 365 calls to Microsoft Graph, which result in a reduction of the number of calls that are made while establishing a connection. This slide shows a side-by-side comparison of a connection to a Windows Cloud experience, the exact same virtual machine on both ends, before and after these improvements were made. Both the left and right side videos show a connection to the same machine under the same conditions. As you can see, before the improvements were made, it takes up to 23 seconds to connect to this target machine. On the right side, after improvements were made, it took just under 7 seconds. This type of improvement is something we can expect to see across all of our users' baselines, even though the timings were recorded under average conditions. Note that these improvements will accrue to both AVD and Windows 365 experiences.
How awesome was that? I would love to get connected to my cloud PC as well as AVD desktops faster than 10 seconds as well. Now over to Jordan to talk about some of the improvements that we are bringing in the peripherals area.
Thanks, Sandeep. I want to talk about a new upcoming feature we have in the redirection space focused on drives and folder enumeration performance. In this demo, what you'll see is that on your left, we have a user who has enabled drive redirection performance for their Azure Virtual Desktop or Windows 365 PC, and they have connected their local storage to their remote session, which is now accessing them. In this example, they are accessing their C drive, which has a little over 4,000 folders in there. And as you can see, it is taking a very long time to enumerate. As we strive to have like local experiences, this is everything from the connections that Rinku is doing to the graphics and connection speed that Aang is doing, as well as local access to your files, folders, peripherals, etc. And so after investigating the root of the issue, we discovered that having a high RTT or round trip time directly leads to this degradation in folder enumeration performance. And so to address this, as you've seen on the right, we implemented something incredibly revolutionary that's never been done before. Caching. All jokes aside, though, by caching and prefetching all of this information, we've been able to take that enumeration performance from over 5 minutes down to less than 7.5 seconds, which is much closer to what you would expect on a standard endpoint device. This feature will be shipping in late February, early March through the Windows Update pipeline. In order to enable this, IT admins will need to set a registry key on their remote session hosts in order to light this feature up. We'll be providing more details on this feature as we get closer to GA. This is just one of many features that we are looking into for Azure Virtual Desktops and Windows 365 environments where we are trying to improve this like local performance for Windows machines. Hope you like this demo. Over to you, Sandeep.
Thanks, Jordan. Hope you all liked what we're doing here at Microsoft to deliver like local experiences for Windows delivered from the cloud. If you have feedback for us, please send them our way. We'd love to hear from you and bring in more innovations and solve problems for you. Thank you so much. Thanks to my co-presenters, Rinku, Aang, and Jordan, for making this a wonderful presentation for you. Cheers all. Bye-bye.